This is a quick note on how to deal with vectors, namely forces, that are not pointing directly towards x or y direction. So we choose normally the x and y directions like that, like in maths. And now this vector force F is not along x or y. So we divide this vector to two different parts. The one that affects on horizontal direction x, and another part that acts on vertical direction y. Okay, so to do that we need to know the angle, either angle, this alpha or the one next to it, and how large the force itself is. Now I'll just give it a number. The force is something and the angle alpha is some other value. I'll just give values now. So I say that force is, say, 40 newtons, and the angle alpha that is drawn to the picture is, just picking a random number, 37 degrees. So what is the effect of force in the x direction and in the y direction? So this F that I drew up there, the 40 Newton force, has both horizontal pull, I write it now Fx for x direction, and then there is the vertical pull upwards, I write it with Fy. And the angle alpha is here as it was before. Okay, so how many newtons are Fx and Fy? How big are these? How many newtons? That's the question. How do I know how large they are? Well, adding vectors together, so with vectors it's always okay to just take the vector from its place. I stole or moved the y component vector there with the dashed line. It's the same vector as that one on the left, just in a different location. Nice thing is here again that the angle between Fx and Fy is a right angle. So there you have a nice triangle that you're going to use trigonometry on. Write expressions for sine alpha and cosine alpha from that triangle. For sine alpha, you get the opposite, Fy divided by hypotenuse, like that. And for cosine it goes Fx divided by F. And from these you can solve for Fy is the same as F sine alpha, and Fx has the length of F times cosine alpha. And if you decide to use the numbers I provided earlier, the force is 40 newtons and the angle was 37 degrees. What you get for Fy, how many newtons up, is 40 times sine 37 degrees, which is something, and Fx gets the value of 40 times cosine 37 degrees. My calculator seems to give for Fy the value of roughly 24 newtons. And the Fx gets the value of roughly 32. It's 31.9, but I'm making it 32 newtons. So the effect of 40 newtons at an angle of 37 to horizontal is that it's the same as pulling with 32 newtons to the right and 24 newtons up. That's what the result here is. So putting this together is that if you have force of 40 newtons at an angle of 37 degrees to the horizontal, you could replace this one force by two vectors, one pointing to the right, one pointing up. 32 newtons to the right and 24 newtons to upwards. Bad English. These two cases give you the same result. 32 newtons right, 24 up is the same as 40 newtons at an angle of 37 degrees. So Fx is 32 newtons, Fy is 24 newtons. This is useful when you have to calculate vectors together. It's sometimes a lot easier to deal them separately in x direction and y direction. That's why we do it.